All right, today we're going to be talking about scatter plots. So we've written equations of lines, but now we're going to actually use our graphing calculators to go ahead and write some equations for lines for us. So we're going to do some scatter plots on there, and then we're going to do what's called prediction equations. They're also called lines of regression. Those should be, or lines of best fit. All three of those terms can be used interchangeably. So prediction equations, line of regression, or line of best fit. We're going to be making scatter plots and then using those. Now I did attach some other videos on YouTube to go ahead and a close-up look of your calculator or the Desmos app. But I'm going to go through a couple problems here, and hopefully you can at least see some of the notes and then also try some problems here to make sure that you know what you're doing. So with our scatter plots, we have some different types of correlations that we can go ahead and say. We can have a positive correlation. That's a positive slope, something going uphill. As one goes up, the other one goes up. And something that's a correlation can be strong or weak. A strong positive correlation means that it goes up and all the dots are relatively close together. Notice they're not exactly on the line. They don't have to be, but they have to be pretty close to each other. Now here's an example of a negative correlation. Now this one is weak because notice we've got some dots that are kind of scattered around. Is it downhill? Yes, most definitely. But there's that one, maybe another one over here that just happen to not really fit. Now the strong and weak correlations is a little bit relative, but we have something called an R value that we're going to go ahead and find later to see whether or not the values are strong or weak. And then there's ones that are just no correlation, that the dots are just all over the place and you can't tell if it's going positively or negatively. All right, let's try one of these. So we want to find a regression line. So here's the table for median incomes of a family, and we're going to use our graphing calculator to make a scatter plot, and then find the line of regression, and then use that line to predict an income. So we're going to go ahead and use this in 3 different steps. So we're going to make the scatter plot, do the line, and then find the prediction. So these values are the values that we're going to have to go ahead and use. You might want to come back to this table in just a minute when we start talking about how to do this. Now again, there's videos to go ahead and go through exactly with a look at the screen on YouTube, but assuming you know how to do that or at least watch that video, you can go ahead and look at this. And these are the values you're going to want to put in. This is going to be your L1 and this is going to be your L2. So we're going to make a scatter plot. So we're going to enter the years into L1 and the income into L2. And then we're going to set our viewing window. We're going to hit the zoom button and then 9 zoom stat. That'll set our window to the appropriate spot. We're going to make sure our stat plot is on, and we're going to graph the stat plot. Once we've done that, we're going to find the equation of the line of regression. We're going to do that by going to stat and over to calc and going down to the linear reg spot. Once you hit that, you should be able to go ahead and you'll get a value right here. Now, it should go ahead and give you an R value. The R value is 0.997, and if it's close to 1 or negative 1, the closer that it is to that value, a 1 or a negative 1, the more strong the correlation is. 0.997, this is a really strong correlation. Negative 0.997 is a really strong negative correlation. If it's lower in the middle, like 0.50, then it's really not that strong. It's a very weak one, if one at all. So the farther we get away from 1 or negative 1, the more of a weak or no correlation we get. Once we do that, we can go ahead and graph that. We can copy that y equals into the graph, and we should get a graph that looks something like this. And notice all those points are really close to that line. That's why it's a really positive, that R value is really close to 1. Here's another one. We're going to use 1985, and this is the percent of people that have applied. So this is years from 1985. So this is 1985, this is 1988, 1991, so on and so forth. And L1, L2 again. Plug those in. you should get a scatter plot that looks somewhat like this, and then we should be able to show a negative correlation. We do have that 1 point off, so if you kind of wanted to say this was weak because of that, I'm not going to be too upset with that, but most of these go through, so we say a strong negative. Again, we can look at that R value and see which one it is. When we do that, we do end up to find the prediction equation. We get M equaling negative 0.4476 and B being 19.19. So my prediction equation is Y equals negative 4.5x plus 19.19. So there's my prediction equation. Again, I can plug it back into the formula, and that's what will give me this line here. Now, how do I find a specific time? How do I do that prediction? Well, I'm going to have to put in my X value. Now, since this is 2010, that's 25 years from that starting of 85. So I'm going to put this 25 in for X. So negative 4.5 times 25 is negative 11.25 or 7.94. So about 7.94% or about 8%. How accurate is the prediction? Well, again, we have to look at our R value at that point. And the R value is pretty high up there, and so we would agree that that is a strong correlation. So we have this one here. We're going to go ahead and years are our X and times are our Y. So you can go ahead and plug that in. Now, the problems here are going to be a little bit off depending upon the calculator that you use, but they should be pretty close. And you want to just pause the video at this point and try this problem out and see how long it takes. And then you want to find in 2015 what the value is. And you should be able to find one of these answers. And 3, 2, 1, the answer is B. And it should look something like this. And that's what I have for you today.